Before there were stars to shine, there may have been a sound too soft to hear. The universe's first whisper, carried by the dark. Not light, but a murmur etched in hydrogen, tugged by something unseen. Today, we are learning how to listen for that first radio signal, dark matter's whisper. This is how we might hear it. After the Big Bang's blaze faded, the cosmos fell into darkness. The light thinned, the fog of plasma cooled, and atoms, mostly hydrogen, took hold. There were no stars, no galaxies, only oceans of hydrogen and a hidden scaffold of dark matter. Dark matter's gravity traced a web across the expanding universe, guiding where matter would gather. This era is called the Cosmic Dark Ages. But even then, hydrogen held a quiet station, a 21-centimeter signal, a spin-flip whisper near 1.42 gigahertz. As the universe expanded, that signal stretched, slipping to lower frequencies, a radio ghost from the dawn. Before the first stars ignited, this was the only trace, hydrogen guided by the dark. Where dark matter thickened, hydrogen pooled. In that tension, the universe prepared its first breath of light. Listening to this era means hearing across 13 billion years, to the hush before dawn. And now, researchers think they know where to tune. In 2025, researchers in Tel Aviv refined models of the Dark Ages, asking a simple question with profound weight. If dark matter pulls more strongly in some places, would hydrogen gather and change the radio sky we expect to hear? Their simulations traced how gravity shepherded neutral gas into gentle clumps along the web. Hydrogen's 21-centimeter signal would brighten or dim with those flows. A pattern, a fingerprint of dark matter. Stretched by expansion, the first whispers drift to tens of megahertz, well below your FM radio band. The models predict subtle clumping, not a shout, but a sway in the background, measurable if we know where to listen. Compare two universes, one smooth, one gently corrugated by dark matter. The radio line changes shape. This spin flip is tiny, rare, but across cosmic volumes, it becomes a canvas the early universe painted on. Arrays on Earth already chase this signal. They map later epochs, where noise is less severe. But the Dark Ages fall lower, where the ionosphere and human noise crowd the dial. If the clumps are there, the sky's radio glow will ripple, not randomly, but with a structure only gravity can write. No starlight, no fireworks, just the quiet choreography of mass and time. Detecting this would turn a theory into a measurement, our first hearing of the universe before the first stars. It links the 21-centimeter brightness to matter power, from the smallest ripples to the vastest sheets of space. A roadmap, not a headline, guiding how and where to search next. It tells us the whisper is patterned, and patterns can be found, if only we could hear past our own noise. The universe is quiet, Earth is not. The frequencies we need are crowded by our own inventions: radio, TV, satellites, storms of static. Even the ionosphere itself warps and reflects low-frequency waves, masking the sky beyond. To hear the Dark Ages, we need a place the Earth can't shout. There is such a place, the far side of the moon. When the moon blocks Earth, it casts a radio shadow, a natural sanctuary of silence. No atmosphere, no storms, no cities, just regolith and the oldest quiet we can stand upon. Here, the universe comes in clean. The cosmic whisper remains faint, but no longer drowned. So we plan to listen from the moon itself, with simple antennas, patient time, and the quiet to match. When Earth slips away, the Dark Ages rise. Teams are already building the ears. From orbit, from landers, from arrays unrolled across the dust. One concept is DARE, the Dark Ages Radio Explorer, an orbiter designed to listen when the moon shields Earth. As the spacecraft glides into the radio shadow, it opens its ears to the lowest, oldest stations of the sky. Simple antennas, precise calibration, and endless patience. On the ground, experiments like Lucy Night aim to prove the quiet and test the hardware for long, dark listens. Arrays could unroll across a crater, dozens to thousands of little ears forming one great listener. Robots can lay the lines, stitching a telescope from the simplest parts, shield the electronics, cool the receivers, and listen through lunar night. Then calibrate, subtract the foreground Milky Way glow and the instrument's own reflection of itself. Store the quiet. Send it home in brief windows when the Earth returns. Across time zones, teams watch the spectrum, night by lunar night. What we seek is a curve, a shallow dip where hydrogen absorbs the background, shaped by temperature and density. Dark matter's pull would modulate that curve, a fingerprint of structure before light. We test against simulations, hunt systematics, and ask the data to argue back. If a feature survives every doubt, then the whisper becomes a signal. And if it doesn't behave as expected, the story gets even more interesting. Suppose we listen well, and the signal is off. Not where, not when, not shaped as predicted. That would mean our map of the dark is incomplete. Perhaps dark matter is warmer, smoother, or interacts with ordinary matter in ways we have not seen. First, we would doubt ourselves. Instruments, software, foregrounds. Then, if the oddness remains, we would doubt our physics. New simulations would bloom, testing dark matter recipes against the pattern in the sky. Conferences would hum, arguments would sharpen. This is how science breathes. Either way, a result, right or wrong, would refine the truth. Because this is not just a signal. It is a test of what the cosmos is made of. And we are about to listen. Imagine hearing the heartbeat of creation, not with ears, but with patience. A rise and fall inscribed in hydrogen, counting time from the first moments of structure. We have always listened to the night. Now, we are learning its oldest language. Turn the dial, hold your breath, let the quiet speak. If we hear it, we will have met the universe before it learned to shine. And if we do not, we will learn what the dark is not. And that is a gift, too. Because listening is how we join the cosmos, with humility, with wonder. Across unimaginable distances, a pattern waits for us, a whisper from the dark. Soon, antennas will rest on lunar dust, tuned to the oldest station in the universe. Orbiters will listen in the moon's quiet, one pass at a time. The faintest data will cross the night to reach us. The cosmos is still whispering, and we are learning to listen.